to Unit 5, Section 5, and we are still talking about the scaling like we did yesterday. And remember, to find our new area, we multiply by our old area by scale factor squared. So we're going to do that some more today and just add a little bit more to it and maybe go backwards. So yesterday's cool down, this is it. It says a 6-inch by 10-inch rectangle is dilated by a factor of 3. What is the area of the dilated rectangle? Well, when the beginning, the original rectangle is 6 by 10, so that's 60 inches squared. We take our square factor and we do 3 squared, which is 9, and then we multiply 60 times 9, and we get 540. All right, go to page, I think it's 547. If it's not, find Unit 5, Lesson 5. And here we go. So remember, when you're watching these, if you need me to slow down, pause it, rewind it, whatever you need to do to be able to understand this. So the image shows that the Transamerica building in San Francisco is shaped like a pyramid. Now, it has some wings on there and everything, but the basic structure is a pyramid. Looks like a square pyramid. Our rectangle, there we go, 53 by 44 meters. The top floor of the building is dilated, is a dilation of the base by the scale factor of 0.32. That's below 1, meaning this floor is smaller than that bottom floor. They may be talking about this floor, but it doesn't matter. It's smaller. Ignoring the triangular wings on the side, what is the area of the top floor? So what is the area of the bottom floor? Well, here it is, 53 by 44. So we're going to put that in our calculator, and we get this. Here's our scale factor. What is 0.32 squared? It is 0.1024, and you're going to multiply that by 2,332, and you get this. And it's meters squared. So a little bit bigger than a foot squared. A little bit bigger than the tiles that are on our floor in our classroom. All right, turn to the next page. It says a triangle has the area of 100 square inches. It's dilated by a factor of 0.25. Here's this first one. May says the dilated triangle area is 25 square inches. Lynn says the dilated triangle area is 6.25 square inches. So I need you to tell me, is May right or is Lynn right? Tell me which one you agree with and why you don't agree with the other. Remember how we do this. We take our old area, our original area, and multiply it by this squared to get our new area. And they have two different things of which one's it. So I need you to answer this on number 1. You can pause it, answer it, write stuff out, and come back and meet me at number 2. All right, so now we're going to calculate the area of the image if the original triangle is dilated by each of these factors. So our original triangle is a 100. Okay, so we're going to do 9 squared, which is 81 times 100. So you get 8,100, and did it say inches squared? So do that with B, and remember, when you multiply our square fraction, we're going to square the top and the bottom, and you can give me a decimal. You can just put 9 divided by 16 times whatever that original was. Okay, come on over to this third activity. It says an artist painted a 1 foot square painting. So if this is a 1 foot square painting, there we go. She painted that painting. Now she wants to create more paintings of different sizes that are all scaled copies of her original painting. So they will still be squares, they're just not going to be the same size. The paint she used is expensive, so she wants to know the size she can create using different amounts of paint. Suppose the artist has enough paint to cover 9 square feet. If she uses all her paint, by what scale factor can she dilate her original painting? So we go from 1 to 9 square feet. So what is the scale factor that we had to multiply 1 by to get 3? And 3 here. Answer that there. Then complete the table that shows the relationship between the dilated area and the scale factor. Round values to the nearest tenth. That's 1 place after the decimal. Remember, if there's a 5 or up behind it, you round it up. If there's 4 below, you stay the same. So here's your original. We're going backwards. So before we had the scale factor and we squared it and multiplied it by the original. Now we have the new, and we're just going to take the square root of it. So take the square root of these. Answer those and come back to me. On graph paper, plot the points from the table and connect them with a smooth curve. So let's plot some points. 0 squared is 0. Square root of 0 is 0. Square root of 1 is 1. The square root of 4, so we're going to go 1, 2, 3, 4, is 2. So up 2. There's that. Our next perfect square is 9. So 4, 5, 6, 7, 8, 9. And the square root of 9 is 3. And if you look carefully, this is not a straight line. It goes like this. You should have graphed something like this in Algebra 1. Maybe with Desmos, I don't know. But it is this graph. And you see it's a curve. The further we go out this way, we go up, but it's not at a constant rate. It kind of curves it there. So that's number 3. Use your graph to estimate the scale factor that the artist could use if she had enough paint to cover 12 square feet. So here's 9, 10, 11, 12. So up to maybe about 3.5-ish, maybe, I would think. Write that down for number 4. That would be the scale factor there. Suppose the painter has enough paint to cover 1 square foot and she buys enough paint to cover an additional 2 square feet. How does this change the scale factor she can use? So 1 square feet, right? Our feet squared. Let's do that. 2. If we go 1 plus 2, you get 3, right? 3 squared is 9 square feet. Actually, that's backwards. Square root of 1 is 1. Square root of 3, we did it backwards. So let's find the square root of 3. You hit second, x squared, 3, and you get about 1.7 feet squared. Do the same thing for 6. So I added 1 times 3 and took the square root. 1 plus 3. 1 plus 2 and took the square root. All right, so now, if you're looking at this table, here's what you should have done on that problem, okay? and it kind of helps you. They're not using each little line as one. It looks like over here they're going 2 lines up is 1 unit. So we did it backwards. In 5-4, we had our scale factor and we squared it to multiply. Now we have the original, so we got to take that square root of that to find what our scale factor was. Our original was 1 on all of these. Okay, so let's go to our purple pages. I'll work through some and you'll be responsible for the rest. A circle with an area of 8 pi square centimeters. So we have a circle. The area equals 8 pi centimeters squared. Is dilated so that its image has an area of 32 pi square centimeters. What is the scale factor of the dilation? So we're going to take 32, divide it by 8, you get 4. What is the square root of 4? We're not dividing 4, we're square rooting it. Hit second, x squared, 4. And what do you get? Okay, on number 2, we're doing the same exact thing, but we're getting an answer for each of these. So I'll do one of them with you. We're going to take this, because it says a trapezoid has an area of 100 square units. What scale factor would be required to dilate the trapezoid to have each area? So we have 6,400. The original was 100. So we're going to divide by 100. We didn't divide by 1 in this over here because it's 1. Our original was 1. Anything divided by 1 is itself. But now our original is not 1. So we've got to do some division there. Okay, so this comes out to be 64. Take the square root, second x squared 64, and you get 8. K equals 8. That is our scale factor. Remember, K is just called K for a scale factor. Like M means this slope in y equals mx plus b. So K is a scale factor. So you're going to do the same thing for these next 4. And when it's less than 100, like right here and right here, you're going to end up with a decimal because you went smaller. Okay, the triangle has an area of 6 square inches and a perimeter of 12 inches. Suppose it is dilated by some scale factor and the area and perimeter of the image are calculated. Match each graph with the relationship it represents. So you're going to tell me which one is area, which one is perimeter. Do your best on this one. We'll talk about this one in the next video. So, going back to this one, if you look down on the bottom, you have graph ABCD. Which one does it go with? So do your best. We'll come back to that one on the next video and look at it. Okay, a polygon with the area of 10 square units is dilated by a scale factor of K. Find the area of the image for each value of K. This is what we did in the lesson before. So we have our scale factor. We're not going backwards now, going forwards. Scale factor is 4, so 4 squared is 16 times our original, which is 10, which equals 160, and it is units squared. Do that for these 3. A parallelogram ABCD prime was obtained by dilating this one, using A as the center of dilation. What was the scale factor? How many did it grow? Okay, 1 is not the answer. How many congruent copies of this one can you fit in this one? How many can you fit in there? How does the area of a parallelogram ABCD prime, that's the big one, compare to the original one, the blue one? Is it bigger? Is it smaller? Is it a dilation? I don't know. You tell me. If parallelogram ABCD, that's the small one, has area of 12 square units, what is the area of parallelogram ABCD? So a prime. So you get your scale factor, square it, and then multiply it times 12. So whatever your scale factor was in A. And let's look at these. Select all solids whose cross sections are dilations of some two-dimensional shape using a point directly above the shape as the center and scale factors ranging from 0 to 10. Which one of these, and there's more than one, I'm looking, there's 3 of them. Which one of these can I cut up, and we'll say horizontally, and you have the same shape, but they're not the same size? There's 3 of them in this answer. Number 7, select all expressions which gives the measure of angle A. So let's look at angle A. And let's look at this one. Arc cosine means, hey, the cosine is that, and I'd have to use that second cosine button in my calculator to give me the angle. So let's look. I'm looking for cosine. Cosine is adjacent over hypotenuse. So my adjacent is 28 and my hypotenuse is 53. So remember, that's what arc cosine is. Does that match this? Yes. Go look through all of them. Remember this. So, ka, toa. Okay, and do those. Now, once you get finished, tear all of the pages from the warm-up to this page, staple it, put your name on it, and turn it in before the bell rings.